Hey guys, and now welcome to your decimals chapter. Hopefully you guys had a chance to watch the lecture on your whole numbers lesson. In this chapter, we're going to do pretty much the same thing we did in our whole numbers chapter. We are going to now just look at decimals. So we are going to add, subtract, multiply, divide, and round with our decimals the same way that we did with our whole numbers. The only difference is in this chapter, we don't look at mean, median, mode, and range, temperature conversions, and military time. So just looking at our operations with our decimals. So we're going to start by taking a look at the rounding. If you recall from the first lecture, we were talking about when we were rounding our whole numbers, we looked at a number, somewhat similar to this. I don't remember the exact number, but if I had 2,947, roundabout figure, I could say I have about 2,900 there, or if we're looking in terms of, if we're saying what if this was money, I have about $2,900, or I have about $3,000. We're going to look at this very similarly. Instead, we're going to look at this now in terms of decimals. So now looking at if there's a decimal, say here between the 2 and the 9. The only thing that changes here is our place values are different. If you recall, now let me erase that decimal again and remind you guys that when this was a whole number, the $2,947, that's the same thing as $2,947.00. Again, we don't have to put those zeros there. When zeros are the trailing end of a decimal, we don't have to write those. But what that made, that 7 in this case, that was again called our ones place. If you remember, the 4 was our tens place, 9 was our hundreds place, and 2 is what's called our thousands place. And then we could keep going if we had more, but we didn't. But again, wherever that decimal is, the number right in front of it is our ones place. So that's 7 in that example again. What I was getting ready to show you guys of what happens, if say the decimal is not there, but the decimal was here. What that means is now the 2 is in the ones place. So the place values that are behind it, 9, 4, and 7, now are different. What we're going to see now, we're looking at fractions of that whole number. If we're, thinking back to money, thinking just to kind of give you a what if scenario over here. Over here, let me show you guys. If, let's say, what if I have $5.10. Now, again, I'm trying to focus on this first place value right after the decimal. But think right now with 10 cents. If I have a dime, that means I have, if we think about, terms of money again, if I have one dime, I still need 9 more to make up a whole dollar. So that means if I have a dime, I have 1/10 of a dollar, is a way to think about that. So that's how that would be read, with that 1 being in that spot right there. That place value is referred to as the tenths place. So tenths. Now we're seeing the TH at the end. Very, very similar. Now let's move that. If I have $5 and now a penny. Now you can see my place value, my 1, has now moved to 2 places after the decimal. And that's why this is a penny as opposed to a dime. If I have just 1 cent, we know that I need 100 of those to make up a full dollar. So 1 would be considered 1/100th of a whole dollar, is a way to think about that. And so yes, that second place after the decimal point is called the hundredths. Sorry, I'm running out of space there, but very same idea that we're seeing that TH there at the end. So you can see kind of the fashion we're taking here. When I look at the first place value after the decimal, that's called the tenths. So going back to our example over here on the left side of your screen, that means our 9 is in the tenths place. Our 4 is in the hundredths place. And now I'm going, again, beyond terms of money, but, if I have any decimal, I'm going to keep counting in the same fashion as I did with whole numbers, except now the only difference is I'm going to the right, and I'm ending these place values with THs. So we're seeing tenths, hundredths, and that 7 is now in what's called the thousandths. You're not going to see anything further than that in terms of rounding with me, but that's what those place values are referred to as, is the tenths, hundredths, and the thousandths, going in that order. So taking this exact same example, so looking at the 2, and I'm just going to rewrite that. So again, that was 2.947. Our decimal is here. So if I said to take this and round this to the tenths place, so round it to the 10th, then what we're talking about here is the 9. So very similar to what we did in our whole number chapter, all of those same rules apply. Everything in front of that decimal or of that place value will stay the same. So the 2 and the decimal that are there in front or to the left remains the same. Technically, everything after that place value is becoming a 0, but with decimals, everything behind, as long as it's the trailing end of a decimal point, those can be dropped if they're the trailing end. So those don't have to be there. But again, we'll see that, and I'll show you guys what happens when they get dropped. But what happens to that 9? Again, one of two things, just like we did before. Either that 9 is going to stay the same, or it's going to round up 1. And again, that's based on the number directly next to it. If that number is between 0 and 4, remember that's considered small, so that means it's going to stay the same. If it's between 5 and 9, that's considered large, so because of that, then it would go up. So because 4 is a small number, that means the 9 remains the same. So actually, the correct way to write this would be 2.9, because we would drop off those zeros that the 4 and the 7 had become. So rounded to the 10th, a way to remember that is when we round something to the 10th place, you're only going to have a number in the 10th place because everything behind it's going to be dropped. So you'll only have one number after your decimal. So let's say we practice with another one of those. Let's say we take, how about 17.58. Now again, let's say I want to round this again to the 10th place. So rounding it to the tenths again. So once again, that's the first number after the decimal. So I'm talking about the 5 in this example. And again, everything in front of that place value will remain the same. So the 17 and the decimal. The 8 is getting ready to be dropped. However, I need to use it to determine what I need to do to the 5. Because the 5 is in the 10th place, so that means that's the value, the last number I'm going to write. It's either going to stay a 5 or become a 6. Because the number next to it is large, I do take it up to a 6. And then again, that 8 is just going to get dropped off. Rounding it to the 10th place, I'm only going to have one number after my decimal. So this is how I would write that, or how I would round that to the 10th place. Looking at a different example, or let's say we go back to the first one, 2.947. Now if I said to take this same number and round it to the 100th place, so now we're looking at, again, sorry, my handwriting is bad on this app here, to the 100th. So now we're looking at 2 places after the decimal point. Doesn't matter what's in front of the decimal. Again, we're only counting, to the right from that decimal point. So once again, it's the tenths and then the hundredths. So now my 4 is in the 100th place. So everything in front of that 4 is going to stay the same. Everything behind the 4 is going to get dropped. But again, either the 4 is going to stay a 4 or become a 5. And that's based on the number next to it. Since the number next to it is considered large, we do take that 4 up to a 5. So that's how I would round that number to the nearest hundredth. Okay. Still moving forward here, looking at just a different example. Let's say I have, 543.298. And I said to round that to the 10th place. Once again, there's my 10th place, right? One number after the decimal. Like I said, does not matter what is in front of the decimal, as again, it's just going to stay the same. Everything behind that 2 is going to get dropped, but I need to use the number right next to it to determine what to do to it. Since 9 is large, I take my 2 up to a 3. So rounded to the 10th place, this would be 543.3. Taking that exact same number, if let's say I said, okay, now let's round this to the 100th place. To the 100th place, that's going to be now my 9, 2 places after the decimal. Once again, everything in front stays the same. Here is where we're going to have a slight exception. Remember what we talked about in our whole numbers chapter. When I look next to a 9, if the number next to a 9 is considered large, then whenever I need to take my 9 up, I'm not going to round it up to 10. I'm actually going to round the place value in front of it as well. So we're going to look at that as if that says 29, and we can take it up to 30. But once again, all zeros behind that place, behind the decimal, as long as it's behind the decimal, can just be dropped off. So this would actually happen to be the same answer as if we rounded it to the tens place. So that was our exception with our nines. Again, anytime a 9 needs to go up, we're going to round the place value in front of it instead. Okay, so that's our rounding. So now let's take a look at addition. So with addition of our whole numbers, treating it just the exact same way we would addition of our decimals, we're going to treat it the same way we did with our whole numbers. If you remember, with our whole numbers, we line those up according to the ones place. So if I had 37 point, oh, I'm sorry, I was comparing whole numbers. My apologies. Let's say 376, and I was adding that to 29. Notice I lined them up according to the 6 and the 9. We're still going to do the same thing, but maybe an easier way to, so we're still lining them up according to their ones place, but even better here that the ones place has a decimal just behind it, so it might be easier to remember we're going to line those up according to their decimal. So when I have numbers behind that decimal, so say 5, 7, and this is 29.4, we're still going to line them up according to that decimal place. Just remember, if I don't have enough values in certain numbers like we do here, what we can do is we can fill in anything with a 0 as long as it's behind the decimal. What I mean by that, I used the wrong marker there. My apologies here. All right. I can fill in this empty spot with a 0 because 29.4 is the same thing as 29.40. We're not changing the number at all as long as it's behind a decimal place or a decimal point. But we're going to add this the same way we did in our whole numbers chapter. We're going to start on the very far right, carrying values where we need to. And then the only difference is where our decimal is in our problem, it's simply going to get dropped down to our answer. So it just gets carried down into that answer. So looking at this would be 7 plus 0 at the end there. So that's 7. 5 plus 4 is 9. 6 plus 9 is going to be 15. So I carry my 1 and add that to the next column. 1 plus 7 plus 2 is going to give me 10. So I put my 0 down and carry my 1. 1 plus 3 is going to give me 4. So that's our addition. Very, very similar to our addition of our whole numbers. Like I said, the only difference is we line those up according to those decimal points if that's easier. Still, again, we're still lining them up according to the ones place, so because right in front of that decimal is the ones place, but easier to kind of see that and visualize those decimals. And then don't forget to bring your decimal down into your answer. So our answer should be 405.97. Okay, now taking a look at the multiplication. With multiplication, we are going to treat I meant to go into subtraction. I kind of skipped over subtraction because it's very, very similar. If I have, let's say, 35.63, we're still going to line them up according to that decimal. So if I had then 19.82, lining those up, we're still going to do the same thing, just subtract the way that I normally would, and then borrowing when necessary. Again, just don't forget to bring that decimal point down into your answer. So looking at this, 6 minus 2 is going to get, 6 minus 2, 3 minus 2 is going to give me 1. 6 minus 8, I can't take 8 away from 6, so once again, I'm going to go to the column just right in front of it, borrow from that place value, always just borrowing 1. That allows me to change that 6 to 16. 16 minus 8 gives me 8. I'll go ahead and bring my decimal down since I'm just moving that direction. 4 minus 9, I cannot take 9 from 4, so I'm going to borrow from the column in front of it. I borrow from the 3 and make it 2. That allows me to make that 4 a 14. Now 14 minus 9 we know gives us 5, and 2 minus 1 gives us 1. So my answer there is 15.81. Remember, if we forget to add that decimal, it's going to make a huge difference there, as 1,581 is drastically different than 15.81, what it should be. So don't forget those decimals when you're bringing those down into your answers. Okay, So now let's move on to the multiplication. With multiplication, a few more steps here, but we're actually going to treat this very, very similarly to how we treated our multiplication of our whole numbers. In fact, we're going to ignore the whole numbers, the decimals in this one, treating them as if they are multiplication of whole numbers. And the decimals actually won't come in until the very end. So if I had, say, 85.32, and I'm multiplying that by, let's say, 1.4. Notice I did not line these up according to those decimal places like I did in the addition and subtraction. And again, that is just because we're just going to ignore those the entire time until we get to the very end. So I'm going to go ahead and start with our 4. Just like we did in whole numbers, we start with a very far right-hand digit in the bottom number, and I'm going to multiply by the top digits moving from right to left as we did in the last chapter. So starting with that 4, so 4 times 2 gives me 8. So I'm going to write this in a different color, gives me 8. 4 times 3 I know is 12. So I'm going to write down the 2 and carry the 1 to the next column. 4 times 5 is 20, plus 1 is 21. So put my 1 down and carry my 2. 4 times 8 is 32, plus 2 gives me 34. And I went ahead and wrote down 34 since I didn't have anything to, another place to carry that 3 to. So that just went ahead and got dropped down. Now I'm going to go ahead and actually get rid of those carried values. I'm going to write my next line down here underneath that 34128. I'm going to go ahead and now multiply that 1 out by each digit of the top number the same way I just did with the 4. Remember, don't forget, when you start a new answer line, you have to then add a 0 with each number you move on to. So I'm going to add a 0 first, and now I'm going to multiply that 1 out. 1 times 2 is 2, 1 times 3 is 3, 1 times 5 is 5, and 1 times 8 is 8. Don't have any more numbers to multiply, so I am finished with that. So I know now that I'm going to go ahead and add these answers together. I get my answer here, 8 plus 0 I know is 8, 2 plus 2 is 4, 1 plus 3 is 4, 4 plus 5 is 9, and lastly 3 plus 8 is 11. So if those decimals weren't actually there, this would be my end answer. What I have to do now is I have to go back up to my problem and take a look at where my decimal is. However many numbers we have after these decimal points in the problem is how many places we will have after a decimal in my answer. What I mean by that is look at 85.32. If I count, there are 2 places after the decimal, or numbers after the decimal. In 1.4, there's only 1. But in my problem altogether, that gives me a total of 3 decimal places in the problem. Therefore, I will have 3 decimal places as well in my answer. So I simply just go into that answer, count 3 places from the end, and add my decimal. And my decimal there, my answer should be 119.448. And again, feel free to use your calculators, guys, to check your answers and see how you're doing on your work, if that makes that helpful. Lastly, we want to take a look at division of our decimals. And I'm doing these pretty quickly, guys, just because you all will have the use of your calculators during quizzes and such. So this is something that's just kind of helpful as you go through the division, and knowing how to do it by hand is very, very helpful. But looking at our division of decimals, what we're going to do, we're going to line them up in that bracket formation the way that we had done before. So 64, let's say 0.25 divided by 4. I'll go ahead and work through this one. So again, yes, you can, you'll be able to use your calculator, but walking through this to see what this would be, we're going to walk through this by hand first. So first, starting with the 4 into the 6. 4 will go into 6 only one time. So I write that over top of that 6. We said that because 1 times 4 is 4, so I write that underneath, and that gives me a remainder of 2. My next step is to bring down the next value. That makes this now 24, and I ask myself the same question. How many times will 4 now go into 24? And it goes in 6 times. We said that because 6 times 4 is 24, so I get a remainder of 0 when I subtract that. Next step, once again, is to just bring down my next value. That makes this now 2. So now my next question is to ask, how many times will 4 now go into 2? Well, 4 will not go into 2. So once again, we just answer that as 0. And just following the same steps, because we said that, because 0 times 4 is 0, and that gives me a remainder of 2. Lastly, I bring down that last value, that 5, now asking myself, how many times will 4 go into 25? Again, it goes in 6 times, because 6 times 4 is 24, and I get a remainder of 1. Now, here's where I run into a slight problem. In division of decimals, you do not want to have a remainder. You don't want to have something left over. I want to keep going until that remainder is 0. So you may end up having to do this. In that original number up here, the 64.25, remember how I mentioned earlier that you can add zeros all day long to the end of a number and it won't change that number whatsoever. So 64.25 is the same thing as 64.250. But what that does now is it allows me to bring another number down. I'm sorry I'm running out of space on my screen here. Allows me to bring another number down so that now I can keep going with this problem. Now I just need to ask myself, how many times will 4, so here's where I am, 4 go into now 10? Let me, I tell you what guys, let me erase this and make it a little bit smaller on the screen here so we can see where we are. So I'm just going to kind of rewrite this. It was 64.25 divided by 4. I don't need that word decimals up there anymore. Okay. So what we had done so far, I'm just going to kind of rewrite this so we can have it here. 4 went into 6 one time because 1 times 4 was 4, so that gave us a remainder of 2. I brought down the next value, that made this 4. We asked ourselves, how many times will 4 now go into 24? And we said 6 times, because 6 times 4 is 24, and when I subtracted that, that gave us a remainder of 0. Our next step was to bring down the next value, asking ourselves now, how many times will 4 go into 2? We answered that by saying it would not go into 2, so we said 0. Because 0 times 4 is 0, that gave us then a remainder of 2. Our next step was to bring down the 5, making this now 25. And we asked ourselves, how many times would 4 go into 25? We said 6, because 6 times 4 is 24, and then we got a remainder of 1. And like I said, we don't want to have a remainder in division of decimals. So what we did is we could add a 0 to the end of that original number. That allows me to now bring that down, making this now 10. So asking ourselves now, how many times will 4 go into 10? We say 2, because 2 times 4 is 8, and that gives us a remainder of 2. So once again, we're still running into a remainder. So what we can do is we can add another 0 and keep going. And you see here we're going to end up getting to a stopping point, because now that makes this 20. And how many times does 4 go into 20? 4 goes into 25 times. Since 5 times 4 is 20, there's our remainder of 0 there at the end. So the only difference here, if this was 642,500, that would be our answer. But because there was a decimal in this problem, the only thing that happens is that decimal gets brought up to our answer. And if you check this in your calculator, you would see that 64.25 divided by 4 is simply 16.0625. So don't forget, just like we talked about in our whole numbers chapter, using zeros when, it won't go into something. That was when we were at this point. When the 4 would not go into the 2, we answered that with 0. And then with division of decimals, don't forget to bring your decimal up to your answer. And don't forget that you want to keep going until you get a remainder of 0. So what we had to do when I didn't have any more numbers to bring down, we started, with here, we brought down zeros. And we did that only twice in this problem. And I would make sure that I will always give you something like this, where you only have to add 1 or 2 zeros to get to that remainder of 0. And that's what we're looking for on these. So on that one, we were looking with, when we have decimals, we treat it just the same way. The difference was we brought the decimal up to the top. And that was when that number inside the bracket was a decimal. But what happens if the number outside the bracket is a decimal? So if I have, say, I want to make sure that I get something that works out. But let's say 73 point, how about 28? And let's divide that by 0. Well, let me see if this is going to work out. 73.28. Yeah, divided by 0.4, let's say. Okay, so now you notice that the number outside the bracket here is a decimal. In order to do this by hand, yes, I know you guys will be able to use your calculators, but just to show you guys how we would do this by hand and making that kind of helpful here, you want to just get rid of that decimal. You want to turn that into a whole number in order to work it out, and then you can use your calculator to check your answer. What I mean by that, I'm going to move this decimal point as many times as I can just to get it to the very end, and that would then turn it from 0.4 into then 4. In order for us to do that on the outside of the bracket, we have to actually do the same thing on the inside of the bracket to keep it even. Whatever you do outside, as long as you do the exact same thing on the inside, it would keep it as an equal answer. So meaning I would change that inside number to now 732.8. And you'll notice when you go to check this in your answer, after you do this by hand, you will notice that this question produces the same answer as this question. But this bottom one is going to allow us to work this out by hand so that I can see how to do it, by paper. It's much easier to come up with your multiples of 4, like we're going to right here, than it is your multiples of 0.4. So going ahead and walking through this problem. So 4 will go into 7. I know it goes into 7 only one time, because 1 times 4 is 4, so we write that underneath. That produces a remainder of 3. Next step is to bring down that next value. How many times will now 4 go into 33? We know it goes in 8 times, because 8 times 4 is 32. So I subtract and get a remainder of 1. Bringing down the next value, making that now 12. How many times will 4 go into 12? It goes in 3 times, because 3 times 4 is 12. And that gives me a remainder of 0. I still have another number to bring down, so I have to do that. And so we ask ourselves now, how many times will 4 go into 8? It goes in 2 times, because 2 times 4 is 8, and there's my remainder of 0. I can stop when I no longer have any more numbers to bring down, and then I get a remainder of 0. So no more numbers to bring down, a remainder of 0. Don't forget to bring your decimal up to your answer, and you should get 183.2. Again, if you check that original problem, the original problem, which was 73.28 divided by 0.4, it should give you this exact answer. Again, as long as you're moving your decimal the same number of places in both the inside and the outside of that bracket in that division problem, you'll get the same answer as the original one. Okay, guys, so I hope that helps. That's your lecture on decimals. Again, just treating it very, very similarly to our whole numbers chapter. Like I said, guys, use your calculators to check that work on that, and I hope that helps. Have a good day.